Hello everyone, we are Team 5 and we have developed a system which can detect human emotions based on facial expressions as our final project for this course. Before we go ahead, let me quickly introduce you to my team. My name is Nikita and we have Omkar, Kavya, Lakshmi and Purushottam in our team. I would also like to thank Professor Tony Diana for his support and guidance throughout this course. In this presentation, we will be talking about the introduction, the dataset that we use, the methodologies that we use for building the model, the results we got from different models that we had implemented, and in the end, we would also like to give a demonstration of our project that we built. All right. As I mentioned earlier, our topic for the final project is detecting human emotions based on their facial expressions. Let me tell you why we chose this topic in particular to work on this final project. There are two main reasons. The first one is image classification. Our project is based on image classification. Image classification forms basis for the other computer vision problems, and it is really very helpful in many areas including medical imaging, machine vision, object detections from satellite images and many more. Therefore, we really wanted to do something related to image classification and deep learning. Emotion identification has many real world applications. The second reason is that we thought using image classification to identify the emotion or the mood of the user would be really nice. As we researched more about it, we discovered that it has many applications including entertainment, identifying people in crowd, monitoring citizens for suspicious behavior by tracking their current emotional state, etc. Therefore, we decided to go ahead with the entertainment part of this and take our project one step ahead by identifying the emotion of the user and converting it into an corresponding emoji or emoticon which can be used in any social media chat and applications. The next part will be explained by Kavya.
Thank you, Nikita. Yeah. So here I'll be explaining about the dataset part. So first we started clicking our own pictures and making a dataset, but it was a cumbersome task for us. So then we did some research and found that there are two potential datasets which are CK Plus and FER 2013. These are the two publicly available datasets. So initially we have chosen CK Plus because it is much smaller and contained images of higher quality than FER 2013. The pictures in CK Plus are well centered, that is, position of eyes, nose, and mouth are similar from image to image. But on the other hand, FER 2013 are varying from each other. So for better performance and accuracy, we have chosen FER 2013. So to brief about our dataset FER 2013, it contains grayscale images of faces with 48 by 48 pixel in size, and size of the dataset is about 57 MB, and also it contains 7 folders, each represent different emotions. So there are surprised, anger, sad, happy, neutral, fearful, and disgust. So in total we have more than 30,000 images in various emotions. Coming to a distribution of data, here we can see that different emotions have different count. So anger, it's around for 4,000 pictures, and fear is also around 4,000, and sad it's almost 5,000, and neutral is also 5,000, and coming to the surprise it's around 3,000, and happy is around 7,000. So coming to the dataset directory, we have main folder which is a data folder, and it has two folders, train and test. Each folder has 7 subfolders, each of which represents a emotion and has images related to particular emotions. Here this folder structure is important because we make use of image data generator class and flow from directory method, which automatically infers the label from folder structure. So these are the some of the grayscale pictures. As I told already, there are like 48 by 48 pixel from our dataset. Now Lakshmi will take over.
Thank you, Kavya. So, talking about the system architect of our application, a machine learning based approach that we have used is cascade, where a lot of positive and negative images are used to train the classifier. Here, negative image is everything else which do not contain the object we want to detect. Positive image contains the images which we want our classifier to identify. This system captures the live picture through camera, and it is done by capturing the face inside a rectangular box using Haar cascade. Here, the Haar cascade detects face in each frame of the webcam feed. The region of the image containing the face is resized to 48 by 48 pixel and is passed as an input to the CNN. These images are pre-processed and extracted live. The extracted live images is suppressed and feature are extracted for further processing. Then the capture feature is trained, classified, and sent to the comparison model, where the emotions is detected from the saved model and compared. The detected emotion search the corresponding emojis from the stored emoji images. Finally, the output emoji is displayed and emoji is shared immediately when the person changes the expression. Let's understand the working of our application. First thing we see when the application is start is it will turn on the webcam of the device and the picture is captured. Using the OpenCV Hearts Cascade, face will be detected on the captured images and face detection will be pre-processed. This pre-processed image will be sent to the trained CNN model. Model will classify the emotion into the one of the seven category, that is happy, angry, surprised, neutral, disgust, fear, and sadness. Based on this category of the emotion, application will display the corresponding emoji to the next to the video of the user. If the user changes his her emotion, then the emoji will also change immediately. If the user wants to quit, there is a quit button in the UI where user can click a button and it prompts the message asking, are you sure if you want to quit the application? If the user want to quit the application, he can select yes or no button. The workflow will be explained by Omkar. Thank you.
Thank you, Lakshmi. Coming to the workflow, in our workflow diagram, we have six different components. The very first component is getting an input image. So we have two different methods to get an input to our model. First is that we can have a pre-recorded video and feed that to our model to do the classification. And the second method is that we can use our computer's camera and share the live feed with the model and do the classification. The second part is pre-processing. As we saw earlier, our dataset, which is FER 2013, it has only grayscale images, which are 48 by 48 pixels, and our model is trained on that. So what we are essentially doing over here is that any input image we get, if it is colored, we try to convert it into a grayscale image first, which is basically subtracting all the layers from the three color channels and having a single color channel. We also further normalize the data by dividing it by 255, so that all the pixel values ranges from 0 to 1. After that, we do the face detection. For this particular step, we use OpenCV's Haar Cascade to do the face detection. And for the facial feature extraction and emotion classification, we make use of our models. Our models are nothing but a linear stack of layers, and it essentially has six different components. The very first component is convolutional layers. These are the building blocks of our network, and these compute dot product between their weights and small regions to which they are linked. The second part is the activation functions. These are the functions which are applied to the outputs of all layers in the network. We are making use of the activation function ReLU over here, and not the softmax. The third is pooling layers. These layers will downsample the operation along the dimension and significantly reduces the processing power. The fourth one is the dense layer. These layers are presented at the end of NCNN, and they take in all the featured data generated by the convolutional layers and do the decision making. We also make use of dropout layers and batch normalization, which normalizes the output of the previous activation layers by subtracting the batch mean and dividing the batch standard deviation. And then we take this model's trained knowledge and pass it on to a different model which does the mapping of an emotion to an emoji. Next, we will see that we have implemented three different models and tested their accuracies in the results section. So the very first model which we tried was CNN V2 model. And initially, when we kept the number of epochs to very low, we got an accuracy of around 53%. And then we decided to increase the number of epochs for this particular model to around 50, and then we got the accuracy of around 63%. As compared to any other model, this was significantly higher, which we will see in the later stage. The second model which we implemented was MobileNet V2. We can see that in the next slide. MobileNet V2. We particularly wanted to implement this model because this particular model performs well on mobile devices. And especially, our goal is to integrate our application with the social media chat applications, which are mostly run on the mobile devices. So this model was pretty important for us. But the accuracy score which we got was 53%, and even though we tried to increase the number of epochs for this particular model, we did not get the accuracy as expected. So we tried another model, which is VGG19, and uh, over here also we got an accuracy of about 40 to 45% at maximum. And after that, how much ever we kept increasing the epochs, or how much ever we tried to fit the model, the accuracies were not as we wanted it to be. So finally we decided that CNN V2 would be our main model, on top of which we will do the classification. So this is the summary of the accuracies that we got for different models that we tried out. We also tried ResNet 50, implementing the ResNet 50 model for this application, but the results were not as expected. Purushottam will help us with the demonstration part.
So, as we saw in the results, CNNV2 gave us the highest accuracy, and therefore we decided to develop our application based on this model. We increased the number of epochs for this model up to 50, which takes us around 2 to 3 hours to execute. We are now going to see the recording of our model perform the classification on real-time camera feed. As you saw, our model is able to classify the emotions quite well. The next part of the project was to generate an emoji based on the emotion. And for that, we are using transfer learning technique, meaning we save the knowledge, that is weights from our trained CNN V2 model, and transfer it to the new model, which is also capable of mapping a class to an emoji. We have developed a GUI for the same, and we're gonna take a look at it now. Here we are taking random images from the internet so that we can also test it for biases. Future application of this model is like we can integrate this to the social media application, as we'll be using them for chats, so that we can directly transfer emotions to the emojis. And we can also implement in digital cameras, where we can capture perfect picture at perfect timing when the person is smiling. And we can also use it for customizing the environment based on moods and emojis, and also to understand the human behaviors based on system, on speech recognition, facial emotion recognition, and also the body language classification. Thank you.